Welcome to today's lesson. Today we are looking at geometric proofs. So your goal by the end of it should be able to construct simple proofs for geometric shapes. So it's important in doing geometric proofs that actually know the different types of shapes that you might be dealing with. So the first one is a quadrilateral. Quadrilateral is just a shape that has four sides. There's one set of parallel sides. So often in geometric proofs, you would label the corners and then you would say A, B is parallel to D, C. A parallelogram, like a trapezium, but it has two sets. So two sets of parallel sides. Rhombus doesn't have four 90-degree angles, but it has two sets of parallel sides, and all sides are equal. This is absolute because if it's a vector, because vectors also have directions. So square is like all of them combined. Okay, so that's all the different shapes you might work with when O to V. That's not the only way we can get there. We can also go up and then down. So we could go O to T, and then we could go from T to V. O to V. We could also do O to U plus a half of TV, because it's meant to be the midpoint, if that's true. Okay, so we want OU in terms of OG and OV. So equation 3 rearranged. OU equals OV minus a half TV. It's probably good to justify. Sub in to OU equals OV minus half OV minus OT. OU equals a whole OV minus a half OV becomes a half OV, and then minus half minus OT is plus half OT. So therefore, OU equals a half OV plus OT. Rectangle, we need to start by drawing a diagram. So we have the origin. From the origin to point A is vector A, lowercase. From origin to point C is vector C, lowercase. So we have two vectors in here. So to get from O to B, we do A plus C. To get from A to C, so this is the first diagonal, we do minus A plus C. we need to show that it's a rectangle, so the angles are 90 degrees, like we talked about at the start of the lesson, and that the diagonals are equal. It's probably first important to say what A is. Got to do that, so OA equals A and OC equals C. So we assume this here, OB equals AC, or the magnitude at least. Okay, so if we square both sides, it's going to become a dot product. Now this is useful because when we're looking at a rectangle, we have 90-degree angles. And when you do the dot product, you do the magnitude times the magnitude times cos theta. If theta is 90, this is all 0, but we'll get to that at the end. So let's do OB dot OB equals, put the positive first. So side note, if you dot something by itself, because the angle is 0, cos 0 is 1. So you just get the magnitude squared. Dot A, C dot C. So this becomes A dot A is the magnitude squared. A dot C, C dot C. We have 2A dot C. That's the left-hand side. The right-hand side is very similar. Plus this. Okay, so if we put them next to each other now, I've got 2A dot C plus 2A minus A. So bringing this over, bringing this over. So these all cancel out. We're left with 4A dot C equals 0. What does this tell us? If the dot product is 0, then the vectors are perpendicular. So this tells us the side OA, therefore OA is perpendicular to OC. If our assumption here if equals AC. So there you have it. Main things to look for: you've got to communicate all your symbols, explaining to the person marking it what they are. You've got to realize to assume that these are equal, the diagonals are equal. If you square the diagonals, this helps us to do the dot product, expanding it. And you have to remember that when we do the dot product, and the two vectors are the same, the angle between it is obviously 0, and cos 0 is 1. So it's just going to be the magnitude times the magnitude, or the magnitude squared, as you can see here. Alright, I hope that was helpful.